This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 6.5, solving trig equations. If you want to go ahead and get your notebook out, you guys are going to continue on with taking your own notes in your notebook so that you are prepared for college when you get there, because they will not be giving you guided notes. All right, so by the end of this lesson, you will be able to, are you ready for this one? Solve trig equations. All right, so this mainly is review from last year because you did already solve trig equations last year. So we're going to kind of go on an extension of that and go a little bit deeper into the topic. So let's go ahead right off the bat and start with our first example as a refresher. Then we're going to solve 2 cosine x equals -1. Okay, so first thing we need to do is we need to isolate the trigonometric function, cosine x. So we're going to start by dividing both sides by 2. We get cosine x equals -1/2. All right, so the solutions are numbers that have cosine of -1/2. To find them, we have to use that unit circle, and we have to think about where cosine is negative, right? So I know cosine is negative in the second and third quadrant. So that's going to become very important to me. So how we're going to do this is we're going to think about when is cosine x equal to a +1/2. Okay, we want to get that reference angle and work from there. So cosine we know is equal to 1/2 at 60 degrees or pi/3 radians. Okay. So again, that's in that first quadrant, this pi/3. I want it in the second and third quadrant. So we have to use our rules for finding angles, right? Pi minus pi plus the reference angle. Okay, so what we're going to do is we're going to go ahead and we're going to find our 2 angles at which cosine is -1/2 in radians. So we're going to do pi minus pi/3 and pi plus pi/3. Of course, we know that in order to find this, we're going to need common denominators, which we've gotten very quick and easy at. Just go ahead and take that. So this is going to become 2 pi/3, which is in my second quadrant, and 4 pi/3, which is in my third quadrant. Okay, now there are just 2 points on the unit circle from 0 to 2 pi. However, we know that we don't stop after 2 pi radians. We can continue to rotate around. And we know that these solutions are going to be my answers, but also anything that's a multiple of 360 will also be a solution. So another way that I can write all possible solutions is I can say two pi/3 plus 2k pi. Oops. So what that means is plus 2 pi, which is 360. So multiples, k times, multiples of 360. So if I added 360 to 2 pi/3, we're going to get another solution. If I added 2 times 360, I'm going to get another solution. If I added 3 times 360, I'm going to get another solution. Okay? So 2 pi/3 plus 2k pi, or 4 pi/3 plus 2k pi. Okay, so that's how we would represent all possible solutions. If I wanted to show it as degrees, the degrees for this is going to be 120 plus k times 360, and I know I'm writing very small, and 240 plus k times 360. Okay? All right, so we can check these using our calculator. We could talk about that in class. Right now, I want to make sure that you can get it done algebraically. So let's focus on that for now. Okay, so let's look at example number 2. And then we're going to solve 4 sine squared x equals 1. Okay, so again, the goal is to isolate that trigonometric function. So we actually have two things that we need to deal with, and we have that leading coefficient of 4 and then the squared. So we're going to kind of pull that apart piece by piece. All right, so we're going to start by dividing both sides by 4. And then to get rid of the squared, we're going to take the square root, both sides. So this becomes plus and minus 1/2. Square root of 1 is 1, square root of 4 is 2. Okay, so again, we're going to use that unit circle to figure out where we're going to have solutions, okay? Since we're talking about sign being both positive and negative, we're actually going to have a solution in every single quadrant. All right? So when is sine equal to 1/2? Well, sine is equal to 1/2 at 30 degrees, or pi over 6 radians. So if I want to see where all my possible solutions are, we're going to go ahead and find this in all 4 quadrants. So quadrant 1, we know is pi over 6. Quadrant 2, we have to do pi minus pi over 6, which, again, we need that common denominator. 5 pi over 6. Quadrant 3, we're going to do pi plus pi over 6, or 7 pi over 6. In quadrant 4, you're going to do 2 pi minus pi over 6, or we could say 12 pi over 6, 11 pi over 6. Okay. So now to write these as all possible solutions, we do have to tack on that extra piece that we just talked about. So we have pi over 6 plus 2k pi, 5 pi over 6 plus 2k pi, 7 pi over 6 plus 2k pi, and 11 pi over 6 plus 2k pi. Okay, so those are your solutions in terms of radians. We can also look at those in terms of degrees. So we can write that as 30 plus k times 360, 150 plus k times 360, 210 plus k times 360, and 330 plus k times 360. All right, so this is your degrees, your solutions in degrees, and these are your solutions in radians. Okay, where k is any integer. Okay, so in most applications, it's sufficient to just find the solution from 0 to 2 pi or from 0 to 360. We then remember that any multiple of 2 pi or 360 can be added to obtain the rest of the solution. So usually we just stick on that interval from 0 to 2 pi. Okay, so let's look at example 3. And we have 3 tangent 2x equals negative 3. Okay, so just like before, what we're going to do is we're going to isolate that trig function. So we're going to divide by 3. Okay. And then what we're able to do for this one is this one, because of that 2x, works a little bit differently. I'm going to go ahead and take the inverse of a positive one and set that equal to 2x. Okay, and I do have a method behind this madness, okay? So we know that tangent is equal to a positive 1 at pi over 4, or 45 degrees. Okay, so if that has to equal 2x, and what I want is the angle x, I'm going to divide that by 2. Half of pi over 4 is pi over 8. All right? So now we have to go back and look at this. We know we're dealing with a negative tangent, so we're not going to be talking about that first quadrant. we actually want the second and the fourth quadrants. So we have to use our rules to figure out what those are going to be. Okay, so we're going to do pi minus pi over 8 and 2 pi minus pi over 8. So common denominator is going to be 8 pi over 8 minus 1 pi over 8, 7 pi over 8. And this would be 16 pi over 8 minus 1 pi over 8 is 15 pi over 8. Okay. So my solutions Okay, so this is how we learned how to solve these last year. We actually need to take a step back for this because now that we are in pre-calculus, we're actually going to look at this a little bit differently. Okay, so not that this is wrong, it's partially correct. These are two of our solutions, but we're actually going to have 4 solutions. So we're going to kind of backtrack here and start over, essentially. Okay, so everything that we did to start was fine. Okay, we had tangent, of 2x equals negative 1. That was good. So now here comes the tricky part. We're looking for solutions x to the equation when we're on the interval from 0 to 2 pi. Okay? Our interval to our problem. I should have written that down up here. It looked like this. Okay? But because we have 2 times the angle, we also need to take our interval and multiply it by 2. So what this essentially does is it expands the number of solutions we can gain because we're now looking on the interval from 0 to 4 pi. Okay? So what we're going to do is we're going to look and kind of solve out just like we did before when we found that 2x was equal to pi over 4. Okay? So here's where we go from there. Again, we're still correct in saying that we need to deal with the second and fourth quadrants, but we're going to look at it a little bit differently. We're going to find our solutions based off of the 4 pi and then divide all 4 of them. Because again, we're on from 0 to 4 pi. We're going to divide all 4 of them by 2. Okay, so we're going to go around and find all of these solutions. So the quadrant 2, just like before, we did pi minus, and we're going to do pi minus pi over 4 this time, which is 3 pi over 4. Okay, that's within my 0 to 2 pi. Remember, we're going to be going around twice, so I'm actually going to take this and add 360 to that. Okay, another way to say 360 is 2 pi, of course. So this becomes 8 pi over 4, so this becomes 11 pi over 4. All right, so we get 3 pi over 4 and 11 pi over 4. And again, those are on the same place on this unit circle. We're just hitting it twice. Okay. Quadrant 4, we're going to do 2 pi minus pi over 4. Or 8 pi over 4 minus pi over 4. Which gives me 7 pi over 4. And again, I need to add a full rotation to that to get the angle when we're going from 0 to 4 pi. So plus 2 pi or 8 pi over 4. And this gives me 15 pi over 4. Okay, so now we have 4 possible solutions for when 2x equals pi over 4. Okay? So what we need to do now is go through and take each one of these and divide it in half. All right, so 3 pi divided by 4 divided by 2 becomes 3 pi over 8. 7 pi over 4 divided by 2 becomes 7 pi over 8. 11 pi over 4 divided by 2 becomes 11 pi over 8. and of course 15 pi becomes freaking pi over 8. So these become my 4 solutions because, again, because of this 2x here, I have to expand out the possibility of more solutions. Okay, so going from 0 to 2 pi to 0 to 4 pi. So you're adding in a whole other rotation. So those ones are tricky. So the key there is if you have double angle, you need to multiply your interval by 2. Okay, so you're going to get more solutions that way. Because remember, this and this, 3 pi over 8 and 11 pi over 8, are actually in the same exact location. It's just an extra rotation. Okay? All right, so let's look at another one here. Okay, so we'll do one more example here. And we're going to solve 1/2 cosine theta plus 1 equals 1.2108 inches. And we want to be on the interval from 0 to 360 degrees. So notice my interval this time, okay? We're dealing in degrees. Okay, so the first one we need to do is we need to isolate that trigonometric function. So we're going to subtract over that 1. And then divide by half, which we know is the same thing as multiplying by 2. Okay. So you want to make sure that your calculator is in degree mode. And in order to get what the angle is equal to, we do have to take the inverse. Okay. So go ahead and do that on your calculator and see what you get. Okay, so you should have gotten approximately 65.06 degrees. Okay. Since we know cosine is positive, again, remember, you're always checking back on those quadrants. Cosine's positive in the first and fourth, which means we're going to have to find an angle in the fourth quadrant that is going to make this function equal to 0.4216. So to find that fourth quadrant, we know we're dealing with 360 minus. Again, we're in degrees. So we do the subtraction. And we get 294.94 degrees. Okay, so my two solutions are 65.06 degrees and 294.94 degrees. Okay, so we're going to stop there for today, and we will pick up with example 5 in the next video. So please come prepared with any questions, and I will see you guys tomorrow. Bye. Bye.